This is question 4 from the 2014 exam. We're going to take a linear programming problem and write down the first tableau from the simplex algorithm. So before we start writing in the tableau, we need to do a few little translations. So in this problem, we've been given it in the form of a minimization. So we need to rewrite this as a maximization problem. So minimizing z is the same as maximizing minus z. So we're going to multiply both sides by 1. So we want to maximize minus z equals x1 minus 2x2. And then we're going to rewrite our constraints with some slack variables. So subject to, now we're given some inequalities, we want to turn those into equalities. So the first one, we have x1 plus x2 plus s1, so our first slack variable, is equal to 10. The next one, we need to turn that greater than or equal to sign around, so we'll multiply by minus 1, so minus 3x1 plus 8x2 plus s2 is equal to 0. And we also need to turn the last one around, so minus x1 plus x2 plus s3 is equal to 2. Alright, now we're ready to start writing into our table. So we put our variables across the top, so x1, x2, s1, s2, and s3. Now the way we do these problems, our basic variables are our slack variables, so we start with s1, s2, and s3. Now we can fill in the z row, so minus z. Really this should take, this minus z is its whole own column, but because every other row will have 0 in the z column, we just put it on the side and don't worry about it too much. So minus z. Now when we do this, imagine that we've taken these things over to this side, so that we'll get something equal to 0. So minus 1x1 plus 2x2, we don't have any slack variables, and we have 0 over here. Now we can do our first constraint, 1x1 plus 1x2 plus 1s1, 0, 0 is equal to 10, minus 3, 8, 0, 1, 0 is equal to 0, minus 1, 1, 0, 0, 1 is equal to 2. Now we just need to determine which entry we're going to pivot on. So we take the greatest negative entry in the z row. So we look at this row here, and we take, out of all the negative entries, we only look at entries less than 0. We take, the one furthest from 0 is the best way to think of it. So that's this one here. Now we look at all the entries in this column. So we are looking for the smallest non-negative ratio between the resource value over here and the entry in this column. Here it's clear which option we choose because 2 of them are negative, so we pivot on this entry. And that's it, that's all we need to do.